So the goal that we want in AI agents is something that will be able to make decisions by itself, take actions, and do things independently. In this video, I want to look at some of the challenges in the current frameworks and look at a new agent from Microsoft called Magentic-One, which focuses on the idea of making a generalist multi-agent that can do a variety of different tasks. I'm going to cover the key changes that they're making to things that are already out there. And also at the end, we'll look at some ideas that you can take from this to improve your own agents as you're building them. So up until recently, we've had two main sort of schools of thought in thinking about agents. One has been the whole sort of idea of you let the language model do as much as possible. So this, I would say, is like the early versions of Crew AI, where you would see things go off the rails, you would see things get in loops, you would get into all these kind of problems. And then the other style was perhaps something more like LangGraph, where you were really controlling the engineering flow of what was going on by having some kind of graph where you map from node to node what's exactly going to happen. Now, both of these systems have their challenges. Obviously, the style where you leave everything up to the LLM is going to be challenging in that if your LLM makes mistakes, then your whole agent is going to go off the rails and your results may not be good. And you end up having to basically trying to work out lots of ways to compensate for that happening. And that can be seen in things like the agent passing off to the wrong agent, using the wrong tools, getting in a loop, all those kinds of things. The second way of really strictly controlling the flow of the agent is really good and much more reliable, but it also requires a lot more work. And it also means that your agent gets to be a very specific kind of agent in here. So one of the things that Microsoft's been working on and released last week is called Magentic-One. And this is one of the early approaches at doing a generalist multi-agent system. So the idea here is that you want to not over-engineer the flow, but you also want to make it so the multi-agent system is not going to get stuck in loops, is not going to generate bad results out, etc. So the key thing that Microsoft is trying to go for here is to basically have a multi-agent architecture where it can generalize to a whole bunch of different tasks without having to have fine-grained, step-by-step instructions as you go through this. Now, the way that Magentic-One approaches this is a little different in a few ways. First off, they've got an orchestrator as the lead agent. The orchestrator's job is to basically choose which of the other agents it will use next in there. In some ways, this is very similar to things that we've seen in Crew AI, things that we've seen in other agentic frameworks, things that you can build quite easily in Swarm, etc. The difference with this compared to the other ones, though, is the other agents. So they've got a series of other agents that the orchestrator can choose to basically pass things off to. So those agents include a web surfer, which is basically a Chromium-based browser and a way to manage state and interact with that Chromium browser. So this is using Playwright under the hood. And the idea here is that this can use the browser to basically go to any page, extract information out of that, input information into that. So it allows us to do a whole bunch of things like clicking, typing, reading, summarizing, answering questions about web pages. The second agent is the file server, and this basically has the ability to read local apps, navigate around your local file system, etc. The third agent, and while I think that they're not talking about this one too much in here, could be one of the really killer things, is a coding agent. So this is a specialized agent for writing code, analyzing information collected from other agents, and then creating new artifacts. So you could imagine that you could use the web surfer to go off and read some docs, etc. And then the coding agent can take that and then start to build something with it. And then the last sub-agent is the computer terminal agent. So this basically has the ability to execute shell commands, install new packages, new libraries, that kind of thing. Okay, so the orchestrator agent is responsible for all the sort of high-level planning, deciding what agent's going to do everything. And another thing that's really interesting here is that the orchestrator's job also is to track the progress. And I'm going to come back to this because this is one of the key things that sets this apart from some of the other things that we've seen before. So the orchestrator will create a plan for how to do this task. It will then gather information to do this. And then at each step, it's going to decide what agent to use and what information to give that agent, etc. Now, this is where it really gets interesting, is that one of the key things that the orchestrator is using is this idea of a ledger. And actually, these are two ledgers. So we've got a task ledger where it's planning what it's going to do. And then it's got this process ledger where it basically updates, okay, what's been done? Has this been completed? What's still left to do from the task ledger that we haven't done? That kind of thing. So it starts off by making its plan and puts that in the task ledger. And then at each step, it creates a progress ledger where it reflects on the various tasks, checks what's done, checks what's not done, and then makes any decisions about assigning things to a subtask or a sub-agent, etc., as it goes through this. Another key element with this is that if the orchestrator finds that, okay, it's not making progress and it's taking too many steps, it can then go back and update the actual plan. By updating the plan, if it's running into errors as it goes through, the idea here is that it will update the plan to work out a new way to get around those errors and then go back to sub-agents or then go back to its next step, etc. So this is probably one of the key elements that actually makes Magentic-One different than some of the agent ideas that are out there already, because it's got these multiple loops of both an outer loop where it's updating the sort of plan, and then this inner loop where it's going through each of the steps of the plan and making subtasks, deciding decisions, that kind of thing, and being able to do sort of reflection steps on that as it goes through. Another idea that they're really going for here is this idea of multi-LLMs or multi-models. Sometimes that might be a VLM in the future. It might be an SLM for a small language model, etc. It might be a specialized, fine-tuned small language model, etc. And the idea here is that you would have sort of one model. In this case, they're using GPT-4o for being like the orchestrator or the main thing. But you could have smaller agents that use very specialized, fine-tuned models that are really good at one particular thing. So you could imagine, if they don't have it in here, one of these could be a sort of RAG agent that you have in there. And that RAG agent might use a fine-tuned small language model that creates answers in the tone of voice of your company or your organization, etc. So if we look at this, we can see that they've got an example where it basically says, describe the latest trends in the S&P 500 using Y Finance. So if we look at the orchestrator's initial plan, it basically talks about, okay, what it's going to use. It's going to use the web surfer, and it decides, okay, what it's going to use the web surfer for. So one of the interesting things here is that even at this early planning stage, it's already deciding which agents to actually use. We can see that after the web surfer, it's going to use a coder, which is a general purpose AI assistant that has strong language skills, Python skills, and Linux commands. And then it's going to use an executor for actually running this. So it's also interesting here to look at some of its sort of chain of thought things that are going on here. So we can see that it's planned out these chain of thoughts of given or verified facts. There are no specific facts or figures given in the request itself. Facts to look up. It's basically got that, okay, it's going to use Y Finance. It's going to look for things like recent highs, lows, trading volumes. Facts to derive. Then it's going to have some educated guesses for this. And I think the educated guesses part is really interesting, and that is setting up in some ways some few shot examples of things that would be in the realm of things that would come out of this. And then we can see that it finishes off with, here is a plan to follow as best as possible. Use the coder to write Python script that utilizes Y Finance library to retrieve latest data, then retrieve relevant information, analyze, use the executor to run the Python script and extract results, compile a brief report on the findings. So after that, the orchestrator kind of scores itself, where it's basically saying, has the request been satisfied? And then it says, no, the request has not been fulfilled yet because we haven't retrieved or analyzed the latest S&P. We've got the sort of in the loop. We've got progress being made. We are making forward progress as the plan is clear. and the next step is to implement the solution. So again, you could think of this as like a chain of thought / reflection step where you're getting the model to think aloud to itself to help it know what to do and what's working, what's not working. Next up, the coder agent writes some code, pretty simple sort of example of using the Y-Finance tool if you've used that before. It's also using pandas in there. And you can see that it basically decides, save this code in a file named SP500 trends and execute it to get the latest trends and data for the S&P 500 index. Again, we go back to the orchestrator. Again, that we can see that the Python script now, again, we can see, is the request satisfied? The Python script has been written to fetch the latest S&P data, but we can see that, okay, progress being made, but still not finished. Next up, we have the executor, which is running the code. It's obviously getting the data back. We can see that it gets the latest info out, and then we can see that, okay, it actually compiles this to a brief sort of summary. So latest closing price, recent high price over the past month, recent low price over the last month, average trading volume. Now, because the request in this case perhaps wasn't super specific, it's not giving a whole bunch of data. You could imagine that we ask it things like, tell me what happened during the day, or tell me what happened each day of this week, that kind of thing. Now, finally, we come back to the orchestrator. The orchestrator basically says that the request for describing this data has been completed. And now it basically compiles that in an easier to read report here. So in their paper, they also have actually benchmarked this entire system to see how it actually performs. And I think this is one of the cool things that we're starting to see with agents is people are actually making proper benchmarks so they can test out how an agent actually does, so that we're no longer just measuring the LLM, we're measuring the sort of agentic system in here as well. So another big contribution that they've done here is they've also introduced AutoGenBench. So Magentic-One is built on Microsoft's AutoGen framework, which is basically the Microsoft framework for building agentic apps, etc. And with AutoGenBench, they've now built a way that you can have a standalone tool for running benchmarks that allows for sort of repetition, isolation, testing out different parts and different components of the multi-agentic system in here. So they look at 3 different benchmarks in here. And while I'm not going to go into this in too depth, I do think one of the challenges at the moment is just how do you benchmark one agent system against another agent system? Really, the code for a lot of these things should be reasonably similar. You're kind of benchmarking the different prompts, the different tools, the outputs and returns from tools. So I've talked a lot about custom tools and how important it is to get information out of tools formatted in a certain way. One of the things that I was thinking about as I was going through this, in many ways, you could look at their sort of sub-agents as tools for the orchestrator, in that the orchestrator here really is passing off to a file surfer agent, a web surfer agent, a coder agent. And it looks at those things as being a tool, but inside each of those agents, obviously they have access to multiple prompts for doing these things, etc. So if you want to try out AutoGen Magentic-One, you can come in and actually have a look at this yourself. This is now in their AutoGen repo, and they've basically got a whole bunch of things for using it. They're recommending using containers with this, which makes sense if you're going to be having something that's going to access a file system, etc. But the cool thing is you can also come in here and actually check out things like, okay, what are they actually using for their orchestrator prompts? How are they actually doing these kind of things? So you can see early on, I talked about the sort of pre-checklists and stuff like that. And you can see here, they've got this, here is a pre-survey, given or verified facts. It wants to come up with these kind of things, facts to look up, facts to derive, educated guesses, etc. for doing these. So you can see that there's quite a bit of a long prompt in here for actually doing this, for actually putting it all together as it goes through this. And if we come into the various agents in here, we can actually go and see what the tools that they've got are, how they're actually using them. You can see here, we've got the tool schema of what they're actually passing through to OpenAI tools and stuff as we go through this. So I think this project is really useful. Even if you're not going to use the whole Magentic-One thing yourself, you're able then to basically learn from both their prompts, how they structured their tools, how they structured their sub-agents through going through this. So overall, just to sum up here, I think the key takeaways from this are that things are moving more to generalist agents. Check out some of the key concepts in here of how they have the orchestrator agent do the different types of planning, use both the task ledger for coming up with the plan, and then a progress ledger for sort of having a sort of scratch pad or a notebook of where it can measure what it's doing and how it's doing as it's going along. Now, the thing that I've heard is that this is an early iteration of this project, and we can expect that there will be more updates around this. You could imagine them over time adding other sort of specialist agents that the orchestrator could use, again, with this concept of being able to have a more generalist agent that can do a wide variety of tasks without it having to be planned out step by step and controlling the actual flow. I do think that Magentic-One is a really interesting project. It's definitely worth you checking out. Like I said, go and have a look at the prompts, go and have a look at how they structure the tools and stuff. I'm certainly going to be playing around with it, testing some of the ideas out here, perhaps taking some of these ideas into other frameworks that I use just to take these lessons away and get my own agents to be better. As always, I'd love to hear from you in the comments. What challenges are you having with building agents at the moment? Like I've been saying to people in my Patreon, I really think nowadays a lot of the challenges are not around coding challenges. They're around designing the prompts for the agent, all these kinds of things. Anyway, if you enjoyed this video, please click like and subscribe if you want to see more videos like this. If you want to see more in-depth videos, please check out my Patreon, and I will talk to you in the next video. Bye for now.